Today, we explain neural networks in machine learning. A neural network is a computational model made of connected artificial neurons. Each connection has a weight, and the network learns by adjusting these weights so that input data can be transformed into useful predictions. A single artificial neuron receives numerical input values. The neuron multiplies each input by a weight, adds the values together with a bias, and then passes the result through an activation function. This is the basic operation that is repeated throughout the whole network. Neurons are usually organized into layers. The input layer receives the data. The hidden layers transform the data step by step. The output layer produces the final result, such as a class, a score, or a predicted value. Training a neural network means reducing error. The loss function compares the network's prediction with the correct answer. During learning, the model updates its parameters many times so that the loss gradually becomes smaller. Backpropagation is the main method used to adjust connection weights. It calculates how much each weight contributed to the error. Then the optimizer updates the weights using the gradient and a learning rate. At the end of many classification networks, raw scores are converted into probabilities. The softmax function transforms a vector of scores into values that add up to 1. This allows the model to express which class it believes is most likely. The main takeaway is simple. Neural networks are layered function approximators. They take input data, transform it through weighted connections and activation functions, compare the output with a target, and update the weights to improve future predictions. The challenge is not only to learn the training data, but to generalize beyond it.